Hello students, let's continue this example. I was just showing you all of these inequalities, the system, which we call constraints. So we've got 3 inequalities this time, and noting that this is x is greater than or equal to 0, y is greater than or equal to 0, makes everything in quadrant 1. So what I did was I made my first inequality purple, and down here, so I turned this off and did this for you. You can turn this off and notice if you let x equals 0 and that gets wiped out, you divide by 20 and you get y is equal to 40. If you let y equal 0 and divide by 50, you're going to get x is equal to 16. So your first inequality I'm going to do in purple. These are the intercepts. Okay, so if you wanted to turn off this video and check it out for yourself, you'll see that that is true. I'm going to show you over here. I'm going to graph 0, 40, which is right here. It's at 40. And 16, 0. See, there's not 16, so you have to kind of guess. And when you put that there, remember to write that down. You may need that 16 later. And now connect these 2 dots, keeping everything in quadrant 1. We're going to decide which side to shade on. So I'm going to put 0, 0 in here. And when you put 0, 0 into this inequality, you get 0. So for your test point, 0, 0, this is going to give you 0 is greater than or equal to 800. Right? So if you put 0, that's gone, gone. 0 is greater than or equal to 800. That is false. So we are going to shade on the other side of this line. So here we go. Go to the line and pull away. And then go to the y-axis and pull away. Because you can't cross the y-axis. Everything's positive. This takes some time, some artistic ability, so you artists out there. And only go to the x-axis and pull away, because everything's in the first quadrant only. So there is the purple inequality. So intercepts everything on the right. Now, for your second inequality, this one here, I'm making it red. I let x equal 0, and when x is 0, wipes that out. You have 15y, and take 480 divided by 15, that'll give you 32. Then I let y equal 0 and took 480 divided by 12 and I got 40. So 0, 32 is over here. And please, if it's not there, like this one had a 40, so I didn't have to write it, but this 32, you might need it later. So 0, 32, and then 40, 0. Well, 40's there, so that's good. And now I'm going to connect these dots. Use a straight edge, preferably. I'm having a hard time doing it with a camera, so we're going to pretend like that's straight. And now we're going to test which side of that red line we're going to shade on. So I go back to the inequality and plug in my 0, 0. And notice if I put 0 in here, that all gets to be 0. So we're looking at 0 is greater than or equal to 480. Which is false. So it's going to shade on the other side of 0, 0. 0, 0 is here, so we're shading on this side. Now it's going to get a little messy. That's why a straight edge is preferable. So I'm going to, let's see, I guess I will just kind of draw this way, another direction maybe. From the red line up. It pays off if you take your time to draw these. And only go to the x-axis because everything's positive. There we go. And there is purple and red. Now notice in this little corner only red is in there. Here only purple. Here nothing. Here's purple and red. Now we've got the green. There are 3 constraints on this system. What are those constraints? They are phosphoric acid, nitrogen, and potash. So what's happening is we're trying to figure out how we can choose our cubic yards of mix A and B so that it meets all of the constraints, requirements for our phosphoric acid, nitrogen, and potash. So last, I'm going to go over here to my green line. I made that, I just put a little green mark here so I can tell which is which. And I'm putting my zeros in. If I let x equal 0, you get y. You take 500 divided by 50, and you get 10, and you let y equal 0, and you get 50 in that last one. So come over here, and we're going to sketch those. So 0, 10 is right here. There, it's right there. And 50, 0 is right there. And now I have to try to graph this. All right. I have to flip it over, excuse me. Not bad. For freehand, I'd rather be using my straight edge, but I can't hold a camera and use a straight edge. I just learned that recently. Now, if I'm looking in some of these places, I have to figure out what's going on. So regions are being, this right here is only red, nothing, nothing, just purple, purple. This is red and purple, I believe, here. Yep. Okay, now I need to know which side to shade my green on. And you may already know. I'm going to put the 0, 0 into the inequality over here. So 0, 0 back in here. And that gives me 0 is greater than or equal to 500. That is false. So I have to shade on the other side. So here we go. I'm going to shade on this side of the green. I think I'll just kind of go like this. Again, those of you who are artistic out there, this is your time. Green line pull, x-axis pull, y-axis pull, y-axis pull. There we go. There it is. Voila. Now, we have to figure out where are all three of these colors overlapping. And certainly not here, or here, or here, or here. Now it's not here either. The green's not in here. And over here, the purple's not. So it is, if you did this all correctly, it's going to be from the 40, this y-axis, and then coming down this line right here, and then coming down this line right here, and then coming over the green line here, and then the x-axis. So I'm going to try to shade that in, including this one here, the red. I just don't want to lose which color line that is. And our feasible region is all of this. Like coloring again. All of this is where all these colors overlap. And this is called the feasible region for this particular farmer. Now what that means is that any of these XY values, cubic yards of A and B, will satisfy the farmer's requirements. Now, we know that's a feasible region. I want to, at one last time, talk about the corner points of only this room here, of only this region that's shaded, all of this. Notice that there's a wall up here. This is a line, so we've got corner points. This is a corner point, this is a corner point, this is a corner point, and this is a corner point. There are 4 corner points here. There are some that are clear. This one, 0, 40. This one is not, so I'm going to call this one A. And this one is not clear, so I'm going to call this one B. This one is clear. It's 50, 0. And with that in mind, I need to find, I've got 4 of them that I need to find. I've No, this one's 040. I had to find A and B. And then I'll have all 4. Just like up above, I had us find not only the region, but the corner points and say if it's bounded or unbounded. We're going to finish like that. So I did this ahead of time, and I wrote down that the corner points, there are 4 corner points. I can write that right here. 4 corner points, 0, 40, 50, 0. Make sure those are in the correct order, A and B. And then point A is the intersection of the purple and the red line. Well, I'll show you that. So A is, here's the red line and the purple line. It's the intersection. So you can't do these all at once. You have to do 2 at a time, or 1 point at a time. So point A is the intersection of the purple and the red lines. So purple and red, I went up and picked the purple here, 50, 20, 800. And red was 12, 15, 480. Did RREF on the calculator. And I got some decimals. All right, so 4.7 and 28.2. That is my point A. Now point B, can you tell me which 2 lines intersect to form point B? The red line and the green line. So I'll turn this over. You'll see that point B is the intersection of the red and green lines. So I took the red equation and the green equation, did RREF, and got 36.6, 2.7. And now I have the corner points are 0, 40, 50, 0. I had trouble writing that, sorry about that. 4.7, 28.2, and 36.7, 2.7. So you check your work and make sure you get what I get, and note that the region is unbounded. If you look at this region here, it goes on and on forever. It's not bounded on all sides. It's only bounded on 1, 2, 3, 4, 5 sides. It has 5 sides here. 1, 2, 3, 4, 5 sides. And it's unbounded. All right, see you later.